Hey guys, welcome. STEMpunk's Friday Aviation Week. Big one, you ready? Now, we've got a really big program today. We took on the task of building remote controlled paper airplanes. We're going to talk you through it today, have a lot of fun with that. We might just first recap a bit from Damo, what we did
This is
last
Michael,
week.
by the way.
Yeah, sorry, I'm Michael, that's Damien, sorry.
I mean, that's the way I do the intros around here. I'm Damo, that's Michael, this is Aviation Week, day 3. That's how we start, just an FYI for next week.
I'm getting rusty.
Yeah.
All right, back into the program. Damo's going to cover now what we're going to do, what we did last week a little bit.
Yep.
Oh, sorry, earlier in the week. So Monday, Wednesday, Friday we do this. We had a big program Monday, big one Wednesday. What did you and the guys go through then?
Okay, so first of all, Monday we went through the designing the future aircraft, did a bit of the design thinking model. That'll be on all of our www.stempunks.com. That's our design thinking model. That was really cool. I'm going to quickly go through some of the shout outs and some of the designs that came through. That was Josh's design, and that was a really cool one because that one came through. And as I said, any of these that come through on hashtag STEMpunks and then at STEMpunksAU, and that lets the team know on what's coming through.
We might just cover Josh's design now. We've got it back up again, right? So Josh has gone to really great extent here to label everything. Annotation is awesome. I love the functionality of his design, eh?
Yeah,
beautiful.
What a legend. Thanks for sending that one in. Next one, Miss K, whoop, whoop, year 6. What I really like is seeing that these programs is going to be starting to be implemented inside schools. So I really like that, teachers are getting involved because we've also got a STEMpunks teachers group. So if any teachers you're out there and you're doing these kind of programs, hit us up, get into that group and let's all have a chat. Like we're all in this together.
Yep, we're just here to support you guys. And finally, we had this amazing video sent in.
Amelia,
so
and
check
I'm
this
7
one out.
years
This is
old.
awesome.
This is my first time on doing STEMpunks, and on Aviation Week, I came up with this. It's a set of sky farmers that will round up animals without the farmer actually being. What does it look like? A set of drones that talk to each other. How will it work? Sensors, special computers, ability to talk to each other, tracking, making wet noises to move the animals. What will it do? Round up the animals for the farmer without him being there. How will it help? It will give him more time. And these are the propellers. That's the body, that's the name, that's the camera around the side. They're the legs. That's the more cameras. Inside is a computer so they can talk to each other. And that is a speaker so they can make wet noises. And that's my invention. Thank you for watching.
Great job.
Awesome.
Great job. Really dig that was our first kind of video coming through as well. What I was very impressed with is that we went through the design thinking process. And then on the design thinking process, we did our quadrants. We talked about what it was going to do, what it's going to look like. And then we built up a prototype. So that's like big cows. That's his there.
Great
so I was really impressed with that whole design thinking process.
Awesome.
Like you did a great job. Thank you so much. And we'll talk about the prizes at the end of this session.
Yeah.
But I was really impressed. And thank you for sending that one in. Make sure you send one next week as well.
It's really cool. So we're getting a lot of photographs coming in of the designs that you're doing through message on Facebook and via email as well. So if you can do video, great. You don't have to, but if you can, that'd be amazing. Otherwise, just send a clip through what you've done because the designs are just awesome coming in. Now, back to what we're doing today. Okay, so we are today going to attempt to make remote controlled paper airplanes. So we went through the design thinking process ourselves. We did the ideation, we empathized, we prototyped, and we went through a fair few different prototypes here. This is one, we got one over here that sort of worked in the end, and we had a few right here too. But we might talk a bit about how do actually aircraft fly. So you and Callum spoke a bit during the week about what we call rotary wing, right? So this is a rotary wing aircraft. I think you guys remember this. It's called a rotary wing because the wing, which is this one here, rotates, all right? So this is just like any other wing. You see a little wing shape right there, it's called an airfoil. and the wind flows over this, and we generate something called lift. So in a fixed wing aircraft, which is this aircraft right over here, it's got a wing as well. It's got one right here, right? So this one travels through the air, and as we can see, wind then flows over this airfoil here, and we generate lift once again. So fixed wing aircraft and a rotary winged aircraft, in this case a drone. It could be a helicopter as well, but the same thing. Now, what we've done here today is that we're going to show you the process we went through, because we said, hang on, how can we turn a very cheap drone into a propulsion system for a paper airplane, all right? So what we've done, we've taken everything out of a small little drone. I'll show you how they worked later on, and we put all that gear onto a paper airplane. And what that allows us to do is to then control this with a remote control, which is pretty cool.
So, did it work first time?
No. So if you ever done any sort of innovation work before, you work with technology trying to design something, innovate something, it very rarely works the first time.
Yeah.
And that's when we look at our, the process we got here, our design thinking process. It's an iteration. It's going round and round and round. And as we go around that circle, we find out really quick what doesn't work.
And how do you know if a plane doesn't work?
It doesn't fly.
And how do you know there's a pilot in the room?
Yeah, well, he'll tell you. We'll come to that later. Now, failure is part of everything we do, right? So we love to fail fast. We've done that with the live broadcast, but everything we do here, we fail really fast.
Yep.
But in doing so, we learn. And we learn really, really fast. And in the end today, we actually did get a really cool airplane. Now, you asked the question, how do you find if there's a pilot in the room? Well, he'll tell you. I'll tell you. So I used to fly helicopters, and we've got our producer, Jono, here. He used to fly fixed-wing aircraft.
Look at him, so smug.
Yeah. So we're going to look at a bit of a video soon. I'm going to talk a bit about this first. Is that, a career in aviation is quite awesome. If you've ever been in an airplane, like a big jumbo, if you've ever been in a helicopter, it's an amazing experience. Now, I've done a lot of things in my life, but learning how to fly a helicopter is one of the most challenging things I've ever done.
So how would a student, let's say there are students that are really, they love building this kind of programs, they love doing the design.
Yeah.
How would a student possibly thinking about maybe if they're getting up our high school, like 9, 8, 10, anything like that, like the high schoolers, where do they go to get into aviation? What's their next step? Yeah,
there's some pretty cool aviation high schools out there that just specialises in aviation. But if you're not in one of those, I recommend going and look at a flight school. There's some amazing flight schools around Brisbane, both on the south side and the north side.
And you
go and check it out.
Just get on, like if you're not in Brizzy, just get onto Google and you'll be able to find one.
Yeah, definitely.
Okay.
So I mean, also for the mum and dads out there, if you want to have a crack at flying a helicopter, it's one of the best things you're ever going to do. You can go up and do a bit of a joyride there, but you can also take control over the helicopter and give it a crack. So it's an amazing experience. I really recommend it. So we're going to look at a video now to get even more inspired about aviation, and this is from a local flight school here in Brizzy.
Cool.
So we'll roll that clip and see if we can get you guys inspired.
6 knots, no, it's just gone up to 7 knots. Stay away, I'll just get you a peek. That would be a maximum 7 knots, but currently on 6. Understood, okay, thank you very much. Only point Delta for runway 32, Jetstar 191. Gold Coast ground, Jetstar 191. Request taxi clearance received, information echo. Ground, that's by Whiskey. And flight plan is for the northern training area, but would like to request amended initial clearance for circuits, for 2 or 3 circuits on information echo. Whiskey Mike Whiskey, taxi to holding point Foxtrot, runway 32. The time is 2:01, and I will advise airways clearance shortly. Whiskey Mike Whiskey, copy. Holding point Foxtrot, runway 32. At above 1,01604. Golf, holding point there. Whiskey Mike Whiskey, copy, hold golf.
Wow.
Yeah.
Now, if that doesn't get you inspired to get up in an airplane and try this out, I don't know what will. That's an awesome
Great little
idea.
advert for the Gold Coast as well. You're welcome.
Yeah, Sunshine Coast.
Beautiful.
Sunshine Coast. And the Gold Coast in the end.
That was
Yes,
the
you're
Gold
right.
Coast.
Yes, it
Like,
was.
I've been there.
It was.
Like,
Moving on. All right, so we're going to build this aircraft now. And as I said before, what we're going to do here, we are going to turn a drone, in this case, something like this, into a fixed wing aircraft like this, basically the propulsion system for that. Now, when we do these classes, now today, I just want you to sit back and learn what we've done, all right? The gear that you need for this, you can get very cheaply. So you don't need that today, just listen through and see how we've done this. So we're trying to be very careful when we pick all the gear that we use here to make sure it's affordable for you guys at home and you can actually get this stuff if you need to. So the drone that we use today is not one of those big expensive ones like this. It's a very, very tiny micro drone. I'll show that in the video later on. It's about 15 bucks from a very known retail store here in Australia. And you can get these things all over the world. It's a very tiny micro drone or a mini drone. So we've basically taken the gear from that drone. In this case, we've taken a few propellers here like this and the flight controller here and also the battery which sits in the middle here. And we put that on top of a paper airplane. Now, I'm going to show you a short clip on how we unbox this drone and then how we put that into our drone frame or the engine room of this paper airplane. Let's check this video out first. Okay, a bit of a process there. So first of all, we're now using a few new techniques here. Like we use things like heat guns and stuff during the week, but we also use things soldering here. So you might have a soldering iron at home that your mum and dad can help you out with. The school normally have that equipment as well. But there's a few safety issues. We just want to bring up safety at the forefront of everything we do. So first of all, we're working with propellers now and drones. So if one of those propellers would hit you in the eye, very, very bad, not good at all. So we always wear safety glasses when we do this stuff. And then the second thing, of course, with the heat guns and that, it's the heat of it. And also with the soldering irons too, being very, very hot. And when we do the soldering as well, we always have a good extractor fan that sucks out all those bad fumes, which can be really bad for you as well.
So if you don't know how to use this stuff, make sure you're getting some sort of advice or adult advice about how to do it, whether it's going to be teacher, carer, parent, anyone like that. Now, can we move it on? So let's break that down a little bit. Now we've just got, we obviously got a paper airplane. Now we've got a drone. How much would that little drone cost, that one that we just pulled apart? Like, are we breaking the bank here? Or?
No, so we bought two of those. They're about $15 each.
15.
Yeah, and you can get them everywhere.
Okay.
Just look for mini drones. They've got a little remote controller like this one here. Comes with a little charger as well. And it's just a very, very, very tiny mini drone.
So now, so it's what we're looking at that video, that a student's going to need paper, they're going to need a mini drone, and they can pull it all apart. Then we're going to need to unsolder some things. We understand it's going to be a bit of tinkering and some trial and error. Like, we've been playing around with this for a couple of days, so don't expect you're going to get this straight off the bat. You know, so just be aware, this is the design, this is the innovation, this is the fun of it, trying to build something that works.
I think also getting your mum and dads involved, and if you're doing this, is a great little school project too, get your teacher involved in this as well. So just recapping, that first video there, what we did was that we pretty much just got to the point of getting all these motors out of the drone itself. So we haven't done this yet. We've basically just taken the motors off, so we're using 2 out of the 4. And I might talk you quickly about how this is going to work. So a drone like this has 4 motors. Now we only use 2 of these, all right? And the reason is this. When a drone flies and it goes from stationary on the floor straight up in hover, it uses all 4 of these propellers to generate the lift and to go straight up. Now when we go forward, when I push the drone to fly forward, it goes like this. What happens is these 2 propellers here, they go faster than these propellers here. And we generate more lift. So the end result is the drone comes towards like this and it flies forward. Now if a drone wants to go sideways, what do you think happens? These 2 go faster than those and it does that, all right? And there is a trick here too. In terms of a drone turning like this, what's called yaw in aviation language, it's these 2 propellers here diagonally rotate one way and those 2 diagonally rotate the other way. So by doing that, we can control yaw as well, right? So we're just taking, basically using the back motors here, because what happens, we're going to put those propellers like this, right? In this direction.
So why wouldn't we use the front ones?
We could use the front one, just picking a pair, right? So we can't pick those pairs there. We have to pick the ones in the back.
And so we couldn't pick the diagonal ones. We have to pick the front ones or the back
Or
ones.
the back one. And the reason is that when you use your remote control, like here, and you put this stick here, which is basically going up and down, right? It'll increase the power to all 4 motors.
Gotcha.
So if I put the propellers like this, it's going to make the aircraft go like that.
Right.
Go
So
forward.
it's like a propeller little plane.
Yeah,
that
same
we're
thing.
building. Gotcha.
Now the beauty of this is that we can also create steering in doing this, all right? So we got the lift, we got the forward going motion, but if we pick the back propellers, if I do this, so sideways motion here, with my left stick on the controller, I will then change the speed of the individual motors.
And so that's going to make the plane go like that?
That's right.
Yeah, right.
So now I can control these 2 motors by the individual speed of the left one and the right one, and I can also control the speed of both. So by going up and down the stick, I go forward like this, not backwards, but forward.
So faster and slower.
That's right. And by doing the sideways motion on the left-hand stick of the controller, I can now turn the airplane either way because I either control the speed of this or the speed of that.
Right.
So that's the trick with this.
And what's going to happen if you go too slow?
It will just die as a little paper airplane because we're using a very modest paper airplane here. It gets quite heavy with batteries and stuff. So if you just threw this thing as a paper airplane, it will just slowly go to the ground. But
I've noticed this one's a bit harder paper.
Yeah,
That's not our usual one that we get out of a printer that we might quickly ransack.
And we'll come back to the next video to where we sort of settle on because we had a lot of prototypes here and we failed fast.
Cool.
So we're just going to go to the next step now. So the first step was that we've now taken the motors out, we've tested the controller to see it actually works. Now we're going to go to the next step and actually start building the actual drone frame. So let's have a look at that. Okay, so cool video. Now we've gone all the way to this point right here. And we want to zoom to maybe the top camera quickly just to show you how it actually works. So basically what we got here is that we've now got what we call our motor frame. So right here, we've got motors on either side. we've got our little circuit board, which is our flight controller. So this bit is really important. We took that out of the drone. That is the little circuit board here that makes everything fly.
So that's inside the casing of the drone. You can see that that's where the two little motors were.
Yeah.
So that is the drone shell.
That's right.
The drone brain.
Yep, that's right.
Gotcha.
That's what makes everything work. And drones like this are quite sophisticated.
Okay.
There's a nice little computer in there that calculates everything to make the drone fly. So we now have our drone frame, which is awesome. We've got two motors. We've got the flight control. The battery is tucked in under here. Now, there's a very important point here called center of gravity. So I've put this boom here, the frame for the motors, at a certain location. I'm going to show you a quick clip now, and I might talk over that, and we can sort of show you what center of gravity is all about.
Yep.
Let's see if we can have a look at that. So we're just going to look at an airplane now, or a paper airplane from the side first. And there is a point that's called center of gravity. So it's basically a balancing point. If you hold a paper airplane, you want to turn it upside down, put under your finger, or on top of your finger, and then balance the plane, you'll find a point where the drone, or sorry, in this case, the paper airplane actually will balance, right? So it actually won't tilt either left or right, just sit there nicely on your finger. So those drawings there just articulates there is a point on the paper airplane where that center of gravity is. So in my case here, if I balance this paper airplane like this on my finger, see if I can do this live, sort of, that's the bad center of gravity. I got it wrong, right? But if I then put my finger in the right spot, I will then exactly get that balance and it'll work like a treat, right? So I'll put this here now. So I measure the center of gravity properly and I put this thing right smack bang in where the center of gravity actually is.
And we've also got like a little arrow, so we're making sure that these two sides are equal.
Oh, very good point.
We don't want to have one further out than the other, do we?
That's right. Because the other thing too is that I've measured the center point here to make sure that is in the center of the airplane itself. But there's another important point too. You might take this outside and try to fly this thing and you start using your controller. And if you go, for example, right, it might go left. What do you think would have happened if it goes the opposite direction to what you actually have set up over here?
I'm going to put money on that you've put the propellers on the different
Yes.
sides.
So there's a few things that can happen here. First of all, we put the motors on the wrong side.
Yep.
Right. So when I do a right stick, the wrong motor comes on. Because if I push right on this controller here, I want this motor to go faster, so it turns like that.
Right.
Right?
Now, would we not be able to figure that out from the angle which the blades would be going?
So that's a different issue, right? So these motors will always spin in a certain way.
Because we can see on this one, if we have a look on this drone just here, the propellers are angled. They're angled for a reason. It's like if you put in the angle on the wrong blade, it's like putting the fan in winter mode.
Yes.
Yeah,
that's
gotcha.
right. That's right. So it's pushing air
gotcha.
in a certain way. And you need to wear safety glasses now because when you start putting the propellers on, it gets dangerous. Now, it won't cut your finger that bad, but if one of these comes off and hits in the eye, pretty bad. So the test you could do is to just feel with your hand, which way is the air blowing? So if you put now, you've got 4 propellers in your little micro drone, right? And if you use the wrong propellers, there's 2 of them are the same as, so there's a pair of propellers, one going one way, one going the other way, so clockwise or counterclockwise. If I put the wrong propeller on here, it'll push air this way. Now in my case, I want this thing here, if it's going to go this way, I want air to go that way, not this way, right?
So the simple test would be put your hand behind it.
Exactly right. To see if the air comes out here, great. If it comes here like a hairdryer, not very good, all right? Cool. Now, we're going to show the final video now. So we had a lot of testing with this thing. We found out that the center of gravity is really important. We also found that using a paper that's slightly thicker than the normal paper is the way to go. So I'm going to show you the clip now of our final flight, and I'm going to talk you through what the lessons learned was from the final design.
Cool.
Then we're going to go into community stuff. Okay, voila, we made it fly.
Lift off.
Lift off, lift off. Now, as I said, there was a fair few goes there to make this work. And you probably also noticed we didn't use this design in the final flight, right? So if you get a snapshot of the design, what we actually settled on up on the screen. So if you look at that photo there, we actually found that the original design with the paper cardboard on top worked fine, okay? But to get a bit more flight distance, a bit more performance out of the airplane, it made a lot more sense to put everything underneath the airplane.
Yeah, right.
So we get a lower center of gravity and the plane will fly a lot better and a lot more stable.
But it's because it's not going to fly forever, is it?
No,
So
it
it's
won't.
eventually
it won't.
going to go down.
It will.
Okay.
But depending on the size of drone you pick for this thing, it actually stays up for a fair while. And this little part that we had here now underneath is now 3D printed. You don't have to do that. You can stick with a cardboard model, the one we had originally. It'll work fine.
And if you want a 3D printing lesson, get onto stempunks.com. We've got cool things up there that you can learn straight away on your own.
And we'll give you the design of this. So if you've got a 3D printer at home or your school got one, you want to make it as a school project, we'll give this one for free as well on stempunks.com. Yeah. All right.
Give it away too easy. You got to work for it.
No, you'll be all good. Send in your stuff. And talking about sending in stuff, we've got a competition going.
Yes. So we've got a competition. We have received heaps of photos, messages and everything. We've got 3 of those planes and they've been going out to, we've been in contact with those winners. Have we got them up there? No, it looks like we don't, so that's all good.
So winners for this, I'll clarify it. So winners for these competitions, we've run this competition all the way through the week and we finished the competition on Sunday. So there's still time to get this done, all right? If you're now looking at your designs, I want to see drawings, I want to see mock-ups, I want to see paper airplanes going really fast.
I'm going to put the challenge out. See if someone can do better than us.
Yeah.
If you can do better than us, then
I think our record was about 20 seconds of flight, which is not that much, but about if you can get more than that, off you go.
And we also still send in those. Have a look at this. This is our launch pad, which is also incorporating the green screen. Oi! That's so cool. Anyway, so that's our launch pad. We've got our prototypes. So make sure you send all these prototypes. Send us in what you're doing, what you're building. Have a bit of fun with it. The last one, we'd love to see some of these remote control planes going around.
Yeah, love to.
I mean, that's the whole point of STEMpunks is we're going through design, we're building tinkerers, we're having fun. So get out there and rip in.
Yeah, and don't be afraid to fail. If it doesn't work the first time, just try again. You might need a bit of a hand from an adult to get that through that stuff, and maybe from your school. But in the end, it's all about having fun.
And if you've given it a go and it doesn't work, still send that in because we love seeing just the effort. Because we haven't shown all the efforts that we've gone to building it and breaking it. So just make sure that you send in those attempts, even if it doesn't work.
And we can learn from you. So send it in, keep talking to us. Now, we've got an amazing week coming up next week. Next week is
Future Cities. Pew, 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 pew. Okay, so Future Cities, it's going to be a really rad week. Can't wait. Again, on Monday, Joe will be in with me and we're going to do a designing Future Cities, some cool things. I know on Wednesday, I'm trying to rustle up some stuff about Minecraft. Don't know how that's going to go because I'm not a pro at it anyway, so I'm still working that out and some more Tinkercad designing buildings. And then we're going to try and get it all into some augmented reality. It's going to be really cool, really weird. I can't wait.
It's going to be fun.
It's going to be lots of fun.
Yep. Fun.
So Future Cities.
Tune in Monday. As I said, competition now finishes on Sunday. Great aircraft to win. So keep sending in the stuff.
Yeah.
I think that's it, Damo. You finished?
Yep.
Good.
Aviation week.
Thanks from us. We'll see you next week.
Yeah.